Okay, guys, so I'm sorry, but I couldn't make it, and it was just working everything until the last minute, but we couldn't make it work. At the end, something happened with the Wi-Fi. We have here the robot that is being kindly provided to us by Robotics, but for some reason, in the last minute, everything was working already, and in the last minute, we got a problem with the Wi-Fi. We cannot connect directly to the robot. So it's a problem of the Wi-Fi, and so there is no connection to the robot. So whatever we do, it's impossible because we need, to connect to the robot through the Wi-Fi. So I don't understand what is happening. I've been working here in the late minutes in a rush, but it's not possible. So we have to abort now the use of the real robot for the class of today. But that doesn't mean that we are going to forget about the navigation part that we have to do today. So we are going to keep moving as we have here with the simulation only. You are going to receive the whole system, the whole notebook, the whole ROSject that contains everything in there. So maybe on the next live class or another day, we'll do a test with the real robot. Now let's start with the simulation, and then as always, let me go to the channel and say hi to everyone that is there. I can see there that there is let me see, Sam is there. Hello, Sam. And C3MX, that's very interesting name. Ikra, hello, how are you doing? They're Capute. In the future, there will be 5G. Yes, in the future. Palav, hello, how are you doing? Haro, Cheryl, Gianfranco, hello, Junjuan, Denisa, Danidas, hello, Danidas. So finally, you, Danny, that you wanted to test on the real robot, we are not going to be able to make you use the real robot from your location. But well, let's do it what we have with the simulation of the robot, okay? So as always, and let's start by sharing the ROSject. Do you remember the old material of the class? We are going to provide it to you by using a ROSject inside the ROS Development Studio. And I'm going to share that with you by sending you on the chat a link that contains all the material, all the notebooks, the simulations, and also the code that we are going to use today. Okay, so let me start by sharing with you my screen so you can see how I'm sharing a ROSject. Remember that you can do always the same thing as I am doing here. It means you can create your own ROSject without a problem. You can use the ROS Development Studio to create your own ROSject and then share with your colleagues, with your students, with your clients, whatever, in order that to provide to them a way of testing your code, your robot, whatever you have. Okay, so that's my screen of the ROS Development Studio. And what I'm going to do is to go to my list of ROSjects that I have. And here you can see that I have the ROSject for today. If I click on it, I have a code button, a link that says share. And here I can copy the code for the sharing. Okay, so let me copy that link and go to your chat, to the chat that you are all there on the YouTube channel. And let me put it there. And in the meantime, oh, sorry. So it looks like it was copied something wrong, a wrong link. Let me do it again. So too many windows here. Yeah, I was trying to do the, yes, here, share, and here it is. Wow, that's very strange, this. Okay, let me copy. And that's it. Okay, so going back to the chat and paste in there. Yeah, there it is. Okay, so now everyone there, you can click on the link and then you will get a copy, a complete copy of my ROSject, the one that we are going to open all together and we are going to practice at the same time. I can see in the meantime, so I'm going to open it. Yeah, so start opening. And in the meantime that you are doing the same thing, that you are opening the project, let me say hello to the people that just arrived to the chat. I can see James, Adarsh, Julian, Charvi, Ahmed, then Sri, and also Commander Cisco, of course, Commander Cisco there. Okay, so I hope that you have clicked on the ROSject link and then you got your copy of the ROSject. And then, as you have seen on the screen, once you have the ROSject there, you can click on the open option and you will get a screen like this one. If you press no now, because we want to start the ROSject from fresh, then the Jupyter notebook will open automatically and then you will see all the instructions for this live class that is contained here. Okay, so today I'm having some technical problems, I don't know. Okay, so this live class, it's about making a robot navigate autonomously. So on the previous two classes, what we did is to make the robot create a plan and then a map, and then we use this map to localize the robot inside that map by using the simulation. In this class, what we are going to do is to use this map and this localization system, and also we are going to include the path planning system that is going to allow us to tell the robot, hey, please go to this location. And then the robot will move by itself to the proper location. Remember that this is a collaboration between the Construct and Robotics company that is the one that has allowed us to have the robot here. And they are super kind guys. They are very professionals. So I highly recommend that you buy their products, please, because they are very good, very professionals in ROS robots. And then let me tell you that this is class number 50. That's very special because, I mean, 50, that's a lot. That's a lot. And then we wanted to celebrate this by using a real robot in our live class. That would be the first time that we use a live class. But at the end, it couldn't be like that, and that's a shame. But anyway, we have another surprise for you. Do you know probably that we are creating an online conference about ROS? It's called the ROS Developers Conference. That's the second edition. So we did it last year also. And that's the second time that we are doing it. It's a whole weekend on ROS learning by using the ROSject at the same time. So we are inviting several speakers from around the world, and they are going to present their stuff, and they are going to teach you different ROS subjects along the whole weekend. It's 8 speakers and 8 practical ROS projects. So for all the people that is attending this live class, you are going to get a free ticket for the conference. We wanted to celebrate this 50 live class and give you some reward. Thank you very much for being there every week, or even if it's not every week, you are here today, and that's what it counts. So if you want to get your free ticket, please send us an email. Here you have the instructions, okay? It's info@rosdevcon.com, and then you indicate that you want to get your free ticket. I have seen that some of the people from the previous live class already bought a ticket, and then if that is the case and you are here, then remember that you can just indicate that you want a refund for your ticket money. So you will get also your free ticket. Okay, so this promotion is valid until the end of tonight in our time, okay? CET time. CET time. Let me include it here because I forgot to hit it, but it's CET time of, it's the time of Barcelona that we have here. Let me see if you have any question about that, and we are going to start very quickly, okay, because we are late. And let me see. Then if there are any question, please put it on the chat. I can see that they, yeah, please. Yeah. Don't say that you want a ticket. Send us an email. We cannot manage it through the chat. It's too complex. So send us an email. You want your ticket. You know that you can see the address there on the notebook. Okay. So go ahead. No questions, I think it's clear. So let's go for the matter of today. And what is that? It's, well, it's about this class, so what I explained you before. We are going to use, again, the Summit XL robot by Robotnik. And the first thing that we are going to do is to launch the simulation. We wanted to use also the real robot that is here. And you have seen there on the camera. And I can put it also there. I think that is a very nice view of the robot in there. Can you do a turn around? Then we can show you a turn. So it's a very big robot. It's very impressive, and when it moves, it's kind of intimidating because it moves with a lot of power, and it's big. So you can see that it goes towards you, and maybe you can get scared. And it has a camera, it has a laser, an IMU, and omnidirectional wheels. So, well, it's a very good robot. And let me go back to the notebook. So let's continue with the subject of today. And so what are the parts that we need in order to get a robot to move autonomously on one environment? Well, that's a map that we already had created on the previous live class. The localization that also we did, the localization on the previous live class. And then we need something that computes the path, makes the robot move along that path, and that also makes the robot avoid the obstacles that appear on the path. So that's what we are going to do today. And as always, we are going to do very, very simple way. You have here more information for your own knowledge that you can check afterwards. We don't need that. I already explained on the previous chapter. So, and also you have a link to the previous live class in the case that you are attending this live class and you didn't have the packages from the previous live class. Don't worry if that is the case, because everything is included in this ROSject that you are having now, that you have opened. Let me know you couldn't open the ROSject or you had any problem, because you need to open it and start working with me in a minute, actually in a second. Let's do it first. Let's launch the simulation of the robot. Okay, so let's go. For that, we need to go to the simulations menu here and select here down the list of robots that are available. Select the Summit XL. Now we got a new screen here. Actually, window, not a screen, and is starting the simulation in there. Let me check if you have any problem in the meantime in the chat. And okay, so I only see that there is C3MX that say hello from Thailand. Okay, great. So I suppose that you are following. Then in some seconds, we should get the simulation of the robot like we had the previous week. So that's no mystery. And what I'm going to show you here is how to create, there it is, the simulation in my case. I don't know, in your case, you can leave it there starting if you want. You can leave it and we can continue. Okay, so here is the robot. Then what we are going to do is to launch the systems that we learned the previous class, how to do them, how to open them. And then what do we need? Okay, so what do we need? I should ask you this in live, but I think that we don't have time to wait for the answers. But what do we need now is first to launch the maps server and then the localization system. Remember that we did a map on the previous live class. Let me show you where we have put it there. Okay, so go to Tools. If you go to Tools and then open the IDE here option. So you have the IDE here, and I'm going to open it. Actually, what I'm going to do is to detach from here and put it as another tab in my browser by clicking on this icon. So if I do this, then I got the IDE here. It's going to open and show me all the files. That's better because it's bigger screen. So we, on the last live class, we created a package in Catkin Workspace source that it's called My Mapping Launcher. Okay, this is the package that we use to create the map. And inside there, inside the config, we put it the my map. You know, do you remember? We created the map and then we saved it. Okay, so this is the map that I created myself, and you also have a copy. And it's a map of the environment inside the simulation. So we can close this IDE because we don't need it. And here in the simulation, if you remember, so we have this environment. I can put it here in full screen. Yes, there it is. So this is the environment that we have, and there is the robot. Okay, so I have created a map of this environment, including the rooms, and I have included here in the ROSject. So you have it here. Okay, is this one. Now, we don't need to create the map now because we already have. So the only thing that we need to do once you have a map, remember this, okay, is to launch the map server. Okay, remember that once you have created a map and saved, you don't need to launch the gmapping algorithm anymore. What you need is to launch is a map server. It's a program that provides an existing map to any other ROS program that requires a map. And for navigation, the localization system requires a map, the path planning system requires a map. So that's why the map server is going to provide that map to it. Okay, so let's do it. How do we launch all this? We need a shell. So let's go to Tools, Shell, and then let's go to the directory that contains the map that I already shown you, and you can copy directly those commands, okay? So I have put it there for your convenience, but I hope that you understand what we are doing, okay? This is for going faster, just that. But if you don't understand, please ask me a question on the chat. So we are on the mapping launcher config, and here we have the file of my map. You can see that there's also the real environment map. Yeah, because I also created a map with the robot, and in this real environment where I am now located. But unfortunately, we are not going to be able to use it today. So I don't know what we are going to do with that. But anyway, you have it there. So now let's launch the map server with the simulation map. So let's copy this, rosrun, map server, and the name of the map that we want to provide. Okay, so now the map server is there, providing the map to any ROS program that requires it. Okay, so now let's go to launch the localization system, and that's the package that we created last week. So it's the same. So it's this ROS launch here. For that, we need another shell. Let's go to Tools, Shell. Let's put it here on top because we don't need to see the output of the map. And you can copy this command. It's actually launching your package, the one that you created last week on the for doing the localization. Okay, so it's that. Basically, is that. Now, we need to localize the robot on the map because this is a localization system, but usually it starts at the random position of the robot. So we can use the RBS to help the localization system to start a pose estimate to indicate to the robot, hey, you are here more or less. So it doesn't start clueless. So let's go, let's do it again. So let's go to Tools, another shell, and we need, for that, we are going to use the RBS, famous tool from ROS. And you know the command, okay? ROS run, RBS. Okay, so it's opening. And let's see. Okay, so in order to see the output of the RBase, you can see that it's not there. We need to open another tool here, and it's called the graphical tools, because that RBase is generating an extra window. So you click there, and it's generating an extra window that is a desktop window, and that's quite tricky. So we devised this solution for using what we call the graphical tools that allow us to see the RBase, and here it is, the RBase. Then another interesting thing is that we have included in this ROSject is that we have provided a config file for the RBase for working with navigation. So this config file, you can find it here. If you go to File, then open config, and then you go to home user. So I have to go one directory up. Here you can see navigation config.rbase. Load this one, and then we'll get the configuration properly for navigation. That includes the laser, the model of the robot, the map, the localization, the particles of the field, of the particle filter, the path trajectories. So it's going to be a lot easier to work with this. And it looks like RBase crashed. Yes, cementation fault. Okay, no problem. Let's launch it again. Yeah, sometimes happens with RBase. Yes. So let's go to File again and load the system here. Okay, so yeah, there it is. So let's load again the config file. One up here, repeat. Oh, it's crashing, very good. Okay, so, okay, today is not the day, definitely is not the day. Let me launch it again, and I don't know, maybe it's because, oh, maybe it's corrupted, that file, because, yeah, I was doing some tests when the network was done. Maybe it's because of that. Yeah, it could be that it has corrupted the config file. Let me try it another time. If it not, then we'll have to go manually again and create it. Discard, and it's crashing. Okay, so yeah. So let's go and do it manually. Okay, so, okay, well, so anyway, you can click here on the blue thing to make it, you can do a double click, and then it will automatically put into the middle. We don't need this area, so we can remove. And also, let's go to Add here. Let's add a map. First, we want to see the environment. So press Add, and then go to look for map. Here it is. Then the map has been added here. Then you can go and select the topic for configuration of the map and select the map topic. Now, if you press like this, there it is, the map that we are using here. Okay, great. So we have the map. Let me see if there is any question here. Then it says, there is a question that says, why you not use Ubuntu from Benito? Yeah, and then, well, we don't use Ubuntu. There is Ubuntu. This is Ubuntu. Here inside is Ubuntu. But my computer is, in this case, is a Mac. I'm using Safari now to show you this demonstration. And what is interesting is that I can program completely in ROS in a web environment without having to install ROS on my computer. That's the point here. That's why we are using this. And also it allows to all of you to practice at the same time the same things that I am getting. So that's the reason, Benito. I think that answers your question. Then Danida says something wrong with the config file because yours also crashed. Yeah, it could be because suddenly when we were about to start with this live class, then the Wi-Fi just dropped down and all the connections that we have were killed. And then the RBase was running in the middle of something, and then maybe that makes the config file to crash. I don't know. Well, anyway, we have here the map. Let's add now the robot. If we press here, add the robot, add, then look for on the list for robot. It's here, robot model. And there it is. We got the robot model there. Okay, well, that's where he thinks that it is. Okay, so it's not correct. Then what else? Now let's add the particles of the localization system. Let me see where the robot thinks that it is. Well, actually it's there because it's showing the robot there. So let's see the particles, then add, and then go down until you find the pose array that is here. Okay, pose array, then you have to configure the topic. Open it for configuration. Where it says topic, then you have to specify the particle cloud. And that's it. Okay, so there are all the particles that the localization filter has launched. So it's where the localization system believes that the robot is. Then by any chance, by this chance, then it looks like it's quite close to reality. So, but that's just luck because of the initialization system, but usually it is not. Remember, if you want to localize the robot on a certain location, you have to press here 2D pose estimate. And I don't understand why it's doing this all the time. Okay. So press 2D pose estimate and then go to a location of the map. For example, here, press, don't release, then move into the direction you want to focus the robot, to make the robot look at, and then release. So all the particles will be set there, and then the robot estimated position will be also shown there. Then that's wrong, because we know that this doesn't correspond to the map. So if I move this a little bit on the other side, let me put it here. Here, yeah. Okay, so we can see here that there is kind of the door here that corresponds to here. This is the corridor, that's the corridor. So the robot is here, just in the intersection of both corners. So that's the position that we have to do. So let's do it again. Pose estimate. Come on, what is doing this? It's very strange. Well, here, then put on the location and signal to the front, and then the particles will change and the robot estimated position also. Okay, so now we have the localization system working. So let's go and create the launch that will allow us to move the robot autonomously. How do we do that? Then we go back again to the notebook here, that we have the instructions. How to move the robot autonomously. So we are going to create a new package. Actually, I already created for you, that is called my move base. Okay, and I already created because I needed to provide you with a move base package for the real robot. So you didn't have to use it, but we are going to create the launch file for this simulation. Okay, and it's the same procedure for a real robot or for your own robot. I'm going to show you how to create your launch file for the move base for any robot, and we are going to apply to the summit, of course. Then, so what is the move base? Okay, the move base is the node that ROS uses to make the robot create a path and then follow that path while it is avoiding obstacles. So in the previous class, we did the node of ROS that allows you to create a map. Then we also did the node that allows you to localize. And in this one, we are launching the node that allows us to create a path and move the robot along that path. That's the move base. Okay, so how are we going to do? Well, we are going to do the same example, the same procedure we did last class. We are going to copy the launch file for another robot, for the Turtlebot robot, that is included into the Turtlebot navigation. And then we are just going to modify the parameters of that for our own robot. Is that simple? Really, is that simple? And this procedure works for most of the robots. I can tell you, it's super simple like this. Okay, so let's do it. Let's open another shell here. And let's do that procedure that is included here. Let me see if there is any question. Junjuan says, connection error, cannot connect the RBAS. Are you still having this error, Junjuan? So that makes no sense to me. Let me know if you have still this error. In the meantime, let's do that. So if you go to Catkin here, if you go to Catkin workspace, let me go to Catkin workspace /source. You can see, you do an ls, and you can see that there is a package that's called my move base here. Okay, so inside the My Move base, there is another launch, and it's there in this launch where we are going to, there is only a launch for the real robot that we are not going to use today, but we are going to put here the one for the simulation. Okay, how do we do that? Well, we are going to copy from the Turtlebot navigation. Let's go. So we go to ROS CD. We do this command that is here. That will bring us with the ROS CD. You know already how it works. So it brings us to the Turtlebot navigation directory that contains the launch of the move base. Okay, so if I do an ls here, you can see several of them. And this is the one that we are going to copy. So we are going to say, oh, I'm going to use the same as in the Turtlebot. Okay, so let's copy it, that one. And how do we copy? Well, we copy like this. First copy, then the name of the file, that is this one that I've shown you, and then the location at which we want to put it, and with the name. Okay, so I'm also changing the name of this launch file from XML to launch, just to make it more clear. Okay, so if you copy and paste that command, then we already have copied that file for launching the move base for a Turtlebot. Now we have to modify the content of that launch file to accommodate our localization, our own robot. So how do we do that? By using the IDE. Let's go to the IDE that was open around here. Okay, it's not. Yeah, it was here on the tab, sorry. And here, if you go to the, inside the tree that we have here, you have the move base, open it, and then inside the launch file, you have both launch files, the one from the robot and the one that we just copied. Open that one with a double click, and here is what we have, everything, the configuration file, a typical configuration file, okay? Contains many, many parameters, but we are going to modify just a few, the ones that usually work for any robot, usually, okay? So that depends then on the specific cases, but as you are going to see, it just works for the summit. Then which ones do we have to modify? Well, those ones, odometry frame ID, we have to provide the frame at which the odometry is being published. Then the base frame ID, this is the center of the robot, okay? Frame, the frame of the center of the robot. Then the global frame ID, this is at which frame it's being published, the map reference frame. So it's the center of the map, this. And then in which topic are we publishing the odometry? The robot is publishing the odometry in which topic? Then in which topic is publishing the laser? And then also one here below that is, which one is the topic that accepts velocity commands? And then I'm just checking now that Junjuan said that he just lost the connection to internet, but now it's okay. Okay, that happens. Yeah, as you can see, it also happens even to us, so no problem. Okay, so we are going to configure those parameters there. And I have provided that here. Well, this is the explanation, okay? So how do we look at that? Well, most of the information here already created on the previous localization files, launch file for localization. For example, if we go to my localizer and then launch, inside the my localizer.launch, we have that information already here. So the, let's say, the scan topic, that is for the laser topic, that would be in this package. The scan topic, what is the name of our scan topic, the one that we put inside the localizer? Well, it is Hokuyo base scan. You can copy from here and put it here. Hokuyo base scan. It substitutes the one that was by default for Turtlebot. This is the topic at which the robot is publishing the laser. Okay, so I'm copying this from here because I already know that I put it there on the previous live class. But in case that you don't know that, how do you do? Very, very easy. You come here to a shell, to a terminal, and then you do a ROS topic list. And then you look for something that is called scan or laser something. In that case, okay, so yeah, so that's not correct because, let me see, this is not correct. Yes, because it's using, so your output is not going to be the same as me. This is because of the topics that I created when I was connecting to the real robot. Okay, don't pay attention to that one. So in your case, you are not having those Summit Excel topics. This is a remnant from my last connection to the robot when I was preparing the class, okay? In your case, you should stop kind of here. So here is where we have to look for the laser or scan, and here it is, Hokuyo base scan. That's why I know that this is the topic that we have to put here, Hokuyo base scan. Okay, so here on the mode phase. So what else? Odometry topic, the same thing. We come here and we do on the ROS topic list, let's check for odom, something like odom, and here it is. So it's just odom. So the default value that we have here is already valid. Then the global frame ID. So I know that is map because we didn't change when we did the map or the map system. So it's correct. It's usually correct. Then the base frame ID. We don't know. We should check on RBIS and also the odometry frame ID. We don't know. We should check on RBIS or looking at the TF topic. So the first, I think that the easiest way is to go to RBIS. So let's go to, again, to the graphical tools that contain RBIS. And I don't know, disconnected. Okay, so I have to launch it again. Today is the day that nothing is working, but we are going to make it work anyway. Yes, there it is. So I presume that I have to create again, yeah, the config file because it crashed, so it didn't save the config file. So let me go very quick. You already have this, so let me go and add those, the pose array, the robot model, and the map. The map is here. And let me configure the topics very quickly. And there it is, one. Then the pose array is also here. And then the one that we need to add that you don't have, okay? The one that you don't have for checking the frames is the TF. So we need to add here a TF. Look for the TF. It's just T and F. Here it is. And that's the one that provides all the frames that exist here in the robot. And for that, we can remove the robot model by clicking here on this tick. You can remove, and then you can see all the frames there. Okay, a lot of information there. So let me remove also the pose array. Okay, that's better. And even the map will help if it is not shown because, yeah, it's clearer. Then on the TF, many things there. So what we can do is to open the configuration of it and then see the tree. You can see the tree here directly. So we see here that there is one frame that is called map. So that's a frame for map. And then another one for odom. So if we come here to our configuration file, then the odom frame ID is called odom. And the global frame ID is called map. Then we need to know the one for the base of the robot. That's the one that remains here. And for that, we can do it easier here. Let me see. It's base link and base footprint. So let me remove all enabled. Just add the base footprint and then add the robot here. Let me add the robot model so we can see where is it showing the frame, and it looks like it's correct. So if I move here a little bit, I can see that this base footprint is on the center of the robot, the projection of the center of the robot into the ground. So that's the one that we have to put in the configuration file. It's called base footprint, the one here. And that's how you figure out which ones are the frames. And we got it. Now, finally, it remains for the common bell, which one is the topic. So let's go quickly to here again to one of the shells and check on the topics. Let's see one topic that is called speed or common bell. And here we have the move base common bell. That is not that one, sorry, it's because of the communication with the real robot. In your case, you don't have that one because you didn't communicate. So here it is, it's common bell. So we already have the proper value here. And that's it. So the launch file has been configured for our robot. Now, the only thing that we need to do is to launch it. And let me see if I'm skipping any step on the notebook. Let me think. No, it's correct. So now we only need to launch that file, and the robot will be able to move autonomously. Almost there. So let's go to this shell and let's launch that file. ROS launch my move base launch. Okay, so that is launching. And there it is. It's starting. I see some questions from Commander Cisco. Just give me a minute and I will answer you. Okay, so that has started the move base node. The move base node, as well as another safety controller. This is, well, that's for another occasion. But then the move base that has been launched. So now we can command the robot for moving around. So if you see here, the robot is there. Let's go to RBase in order to provide to the robot command to go to somewhere. So let me now enable again here the TF. I'm going to remove it because we don't need it, or to unlock. Then the robot model is there, the map, and the pose array. So we can see how the robot is localizing better. Now, let's do one thing. Let's add another element here that is going to be the path. So we can see the path that the move base is generating. Well, before that, let's just provide a goal to the robot to go. Okay, so let's say the robot go to this location. How do we do that? In the same way as you do pose estimate, you have the 2D navigation goal. So click on there and then provide a location, click orientation, and then leave it. Then the robot should start moving towards that location. And also another effect that you can see is that by moving, all the particles of the localization system, they converge into a better localization. So now that means that the localization system is more secure about its guess of where in the map is the robot located. Okay, and you have seen how in the RBase the robot has shown the movement, and also as well as on the simulation, of course. Then the next step would be to connect to the real robot and do the same thing, but on the real robot. So the real robot will move when we provide an RBase goal. But unfortunately, we don't have the time. So let me just add here on RBase a path visualization. So click here on add, and then look for path. It's here. And now configure the path. If you open it here, you select the topic, and then the topic that we are going to do is the let me see. The path is here is I think it's that one. I cannot read it very well here. Navigation. Let me see. Yeah. Okay, so now if we provide another goal, we should see here, for example, here, then we can see, I don't know if you can see on my screen, but there is a green path here that is printed. That is the path that the move base has generated to allow the robot to indicating to the robot, hey, you have to move on this direction. Okay, and that is how you achieve the autonomous location. So instead of launching the goal from here, you can do it from a program. So imagine a program that it's a table. Imagine that it's a robot that is serving coffee on a restaurant, and then you have an iPad that contains the locations of the tables. And then you can provide to the iPad that when the person pushes a button on a table, then it sends a goal, navigation goal to that table. So the robot will go to that table. You can also play by sending the robot inside the rooms and see what happens. For example, that's funny. Let me check in the meantime the questions, okay? So let me go back to the channel on the YouTube. And let me see that I can see that there are some questions. And also, let me skip here my screen. And there it is. Okay, so I see. Commander Cisco says, how do we confirm the global frame ID? Yeah, the global frame ID, it should be also showing there on the ROS. So you can check. You will see that there is a frame ID that is the map. And you should see that on the ROS. Just check it, and then you will see that it says, well, this is a way of doing it. Also, another way of doing it is to generating a PDF containing all the frames. And how do you do that? With a command. Let me show you. Okay, so let me show you that. And you will see that the global frame is on top of everything, of the whole hierarchy of frames. Let me show you how to do that. For that, I need to share again my screen. Start sharing screen, and let's go. And here, too many windows on the same computer. There it is. Then the command, it's called, let me open a new shell. It's called ROSrun TF view underscore frames. If you do launch this command is going to look for all the frames that are published on the TF and then generate a hierarchy in a PDF document. If you go now to the IDE, you can see the file here. It should be here, okay? Let me refresh. So if you refresh the directory here on the user, you can see here the frames PDF. Now you can download here this file if you download it, and then you afterwards you open it. So I'm opening it in my computer. You cannot see, but let me show to all of you how it looks like. So I'm going to share with you this new. Stop sharing that, and I'm going to share this new screen. And there it is. So you can see here the structure of all the frames that are on the robot. And then you can see that there is a frame that is the top of everything, and that is the one that is the global, of course, is the frame that is, everything else is referenced towards that frame. So that's a way of confirming that. So the name that appears here is the name that you had to put into the file. Okay, that name there. Okay, so let me see if there are more questions.